Hello. In today's video, we're going to talk about pricing bonds between coupon dates. And when we price bonds between coupon dates, this is what it looks like. So let's think a little bit about how this works. Most of the time when we are modeling bond prices in this class, we assume that you're purchasing bonds on coupon dates and we price the bonds accordingly. But what happens if instead we're purchasing bonds between coupon dates? We have to figure out a bunch of stuff, like the days until the next coupon payment, how many days? How do we calculate present value with fractional periods? How do we allocate the interest that's associated with these bonds? Remember, interest is earned or accrued daily, but paid semi-annually. So on the solution, what will happen is the buyer is actually going to just pay up front for the interest that he's going to receive in a little bit. And so I want to draw this out for you in a timeline with a bit of an example. So let's take a peek at that. So we're going to share the whiteboard with you, and let's take a look at what we're doing here. So when I buy a bond between coupon dates, I have to deal with the fact that the interest is not belong to one of the different parties, but actually to both parties. And so I'm going to assume that I buy a bond on July 17th. This is my settlement date. And settlement date is just the date that I actually purchased the bond. This bond pays interest on September 1st. And if I count back 6 months, that means that the most prior interest payment was made on March 1st. And so when I purchase this bond, I have to think a little bit about what's happening. So the interest payment, this is a 6-month period, and the interest payment that's going to occur on September 1st is going to belong kind of not just to one party. So the buyer here owns the interest from July 17th on. Prior to that, the interest belonged to the seller. And so when we think about pricing this bond, we have to think about a couple things. First of all, sort of where does the interest go? And second, how do I value a bond that isn't being priced all the way back to the most recent coupon date? The bond actually, if I buy it on July 17th, when that next cash flow comes, I only have to discount that cash flow back for this partial period. And so I have to do some math to figure out what that looks like. And so when we take a peek at the slides here, I have to think about how to do that math. So the first thing we need to do is talk about the number of days between that period, between March 1st and September 1st, and then between those partial periods for which the seller initially owns the interest, and then later the buyer owns the interest. Turns out that day count is kind of hard. First of all, not all days, not all months have the same number of days. So you got to go out and learn that. Once you've learned that, then it depends on the type of bond that you're buying. For treasury bonds, we assume that years have exactly the number of days that they have in them. That is, a non-leap year has 365 and a leap year has 366. And we're going to count the number of days for the full period as well as for the partial periods. And so the first thing we need to do, if we've got this example, settlement date July 17th, next coupon is September 1st, and the most recent coupon was March 1st, we need to count the days in those partial periods. And so let's go and do that in our whiteboard. So let's take a peek at what that looks like when we try to calculate those days. And so first we need to count the days during the whole period. And when we count days, we can write formulas in Excel to do this, although we do have to tell Excel what the conventions are, whether it's a treasury or a different type of bond. But let's first just count the number of days between March 1st and September 1st. Okay, so I'm going to kind of do this over here on the top. And I'm just going to write out each month and do it by hand. So March has 31 days. April has 30. May has 31. June has 30. July has 31. August has 31. And September, 1 day for which I own the bond. Now, when we calculate the days in a total period, we need to worry about what's happening for these partial periods. So I am going to count the days. I want to count the days between March 1st and September 1st. Let's just start with the months for which I hold the bond for the whole period. So I'm going to assume, let's just look at this total holding period as a 6-month period. Don't worry too much about the actual transaction. And we can count the days in April, May, June, July, August. And if I were to buy this bond at some point between March 1st and September 1st, I would own the bond on September 1st. So we're going to count that day. March is the only tricky one. And so the way that we do this is we assume that if the coupon payment takes place on March 1st, it takes place at 5 p.m. or sometime when the market's closed. So the person who owned the bond on March 1st received that coupon payment at the end of the day on March 1st. So if we want to count the days between March 1st and September 1st, we don't count March 1st because that coupon payment was received at the end of the day. We're actually counting days starting with March 2nd. And so we could count on our fingers, but the easiest way to do that for March, we put MR for March, is to take 31 total days in the month and subtract whatever the number is of the date of the coupon payment date. So we actually are going to be owning this bond. If we were to purchase this bond and hold it for this 6-month period, that would be, we would not consider it a day count. We're not counting accrue. We're not going to count interest for March 1st because it was already received March 1st. We take total days in the month, subtract 1, and there are 30 days in this period between March 1st and March 31st. If I add these up, I get 184 days. And so anytime you're day counting for a treasury, remember actual number of days in the month. And then for that partial period, you don't count both March 1st and September 1st because that cash flow came at the end of the day on March 1st. So you subtract that first day, which is what we're doing here. And we get 184 days in the period. We can also count the partial period from July 17th to September 1st. And so if I were to buy the bond on July 17th, July has 31 days. I would also be owning it for all of August. That's 31 days total. And then September, we're going to have 1 day. Now, if I buy it on July 17th, I don't own the interest for that day. Assume I buy it at the end of the day. So to count the number of days in July, I'm going to take 31 days in total minus the 17th, the purchase date. So I'm not counting that. And that gives me 14. August gets 31 and September gets 1, and this adds up to 46 days. So there are 46 days between the 17th and the 1st. There are 184 days total, and so I can subtract 184 minus 46, and I'm going to get 138 days for this partial period. And we're going to use this information when we calculate present value, and then also when we calculate the price of each of the cash flows for the bond. So going back, for treasuries, that's how we do it. Day count is actual. For other types of bonds, corporates, munis, and agencies, we actually do something weird. We pretend every month has exactly 30 days, and then we're going to use that information. If we have 30 days in a month, then we have 180 days in a year. So if we're going to count the days between March 1st and September 1st, that will obviously be 180 days because it's a full 6-month period. And then if we want to take a look at the partial day count, we will then, instead of assuming that July has 31 days, we assume it has 30, and this becomes 13. And we also pretend August has 30 days, and this becomes 30. So we end up, instead, for our day count, we're going to have a total day count of 180 for the full period. Put this here, so we're getting a bit messy. We're going to have 44 days for that period. And then the difference here, 180 minus 44 is 136. So for a muni bond, right, this is no longer true. For a muni or corporate bond, we assume this 360-day year, 30-day month situation. And so that's probably the thing that sort of takes the longest here. And the rest of this is just math. So let's take a look. For a partial period, here's what our cash flows look like. So we're going to buy this bond, and we don't know what it costs right now. That's what we're trying to figure out. And every period, we're going to model out the cash flows, and then these are C's for coupon, and then M for maturity value, par value. Check out the denominator. So here's the deal. We're going to discount each cash flow at 1 plus whatever the discount rate is. We call that R. And we're going to raise it to time in periods. Now, the first period for my municipal bond or corporate bond is a partial period here. And specifically, it's going to be 44 days over 180 days. So that first period for which I discount, which is going to be July 17th to September 1st, that's 24% of a 6-month period. And my numerator here, I'm sorry, my exponent here is going to be 0.244. Note that the buyer of the bond is paying for that coupon payment that's going to come on September 1st. He's not really entitled to the whole payment in terms of who actually owned the bond when, but because he's paying for it up front, he is to some extent entitled for it. And to price it, we just discount at that partial period value. So here's our example with some numbers. Just a few new items here. The required yield is 6.5%, so that's semi-annual 3.25, and each coupon payment is going to be $5 because it has a coupon rate of 10%. So when we put this all together to solve for the price, we're going to take each cash flow, $5 all the way through till the end where you get the 105, and each period. So the first partial period is that W, which is the 44 divided by 180, and then every subsequent period, we add 1 to it, 1 representing a full 6-month period. We price this out with our present value formula for each cash flow, take the present value and we add it up. We call this the dirty price or the full price, and this is what the buyer will actually pay to the seller when he purchases the bond. Note that the accrued interest is included in that price, so he's paying up front for that $5. If we want to figure out how much of the interest belongs to the buyer and how much belongs to the seller, because that's something that is going to be needed for that person's accounting down the road, we then take the number of days from the most recent coupon date to the settlement date. And recall in our example here, we have 136 days between the prior cash flow on March 1st and the settlement date. So 136 over 180 is going to be the ratio of interest that belongs to the seller. And we can calculate that here using this example. So number of days from last coupon period to settlement date divided by number of days in coupon period. So the partial period was 0.24 or so for the July 17th forward. If we go back from July 17th to March 1st, it's 136 days, call it, say, 76%. It's 1 minus that 0.244. And that's how we calculate this. So the accrued interest then is going to be $5, the full payment, times that weight, 136 divided by 180. And the accrued interest is about 378. The full price, which includes accrued interest, is 120.03, which we calculated before. If we subtract the accrued interest, we get a price of 116.25. That's the clean price. It doesn't really mean anything because it's not actually the price that's paid, but oftentimes in the marketplace, we'll quote the clean price so that we can compare bonds to each other. The last thing we're going to learn here is this idea of yield to maturity and how to calculate it. So if you're given a semi-annual discount rate, which would be the internal rate of return, or the R in your discount PV formula, you would double it to get to the yield to maturity. So you can always calculate this using your calculator or using Excel to solve for that. In this prior example, the yield to maturity, in a new example, we've got an 18-year 6% coupon bond with the price 100 par. Calculate all the info about it, and when we calculate the IRR for that, the bond equivalent yield, we calculate the 6-month yields to maturity that we use in the formula, we're going to solve for 4.75. And so that's the discount rate. That's the 1 plus R raised to time and periods. That's the R. If I want to state that as an annual rate, which is called a bond equivalent yield, I can just double it. So 2 times that rate is 9.5%. And that would be the information that would be given if instead I didn't give you the price and said, go price the bond. I would say the bond equivalent yield, the YTM is 9.5. You would divide it by 2 and go use it in the formula. You can also compound that number, which is not typically stated, but is something you should know how to do. We call that the effective annual yield. We're going to take 1 plus that 6-month rate, square it, and subtract 1. And obviously the effective annual yield is higher because there's compounding involved. And to summarize, what we've done here is we've learned how to price a bond between interest rates. We've also learned the concept of yield to maturity and how to calculate.